James Webb Telescope sent back unexpected images. The James Webb Space Telescope captured spectacular images of the galaxies, but what precisely do we have a look at? The James Webb Space Telescope has always had the gravest fortune debatably since its launch, colliding with a micrometeoroid the size of a small grain of sand, but none of the 344 pieces of information that were previously enumerated as things that could go wrong and destroy the entire mission has occurred. The first 5 scientific images taken by the James Webb Telescope were shared with the general public on July the 12th, and the degree of the specifics far lived up to expectations. These pictures convey information regarding the cosmic microwave background, star birth and death, galaxy collisions, and exoplanet atmospheres. It should go without saying that these are not pictures, they are information representations. They are also quite beautiful. This information shows the effect of photons, or light energy, on highly sensitive circuits in 1,000,000 kilometers away. The Webb's telescope's numerous instruments monitor that energy and send it back to Earth, which allows it to be delivered into almost anything human eyes can observe. The smudgy pastel impression of previous telescopes is gone, and the image quality and clarification may make you wonder if what is being painted is light. What do these photographs disclose, and for what? Pictures from the NASA James Webb Space Telescope are data graphical representations. According to Rod Simon, a visual analytics expert at the Remote Sensing Corporation Planet and who was once at NASA, it's a powerful communication technique, he affirmed. While his tasks involved directing space sensors back toward Earth, he experienced the very same difficulties as astronomers who study long-range targets. Scientists from around the world are ecstatic about JWST's revelation. One of the first 5 images was a spectrograph of the atmosphere on a planet 1,150 light-years away from Earth. The new telescope was able to detect water's chemical signature. Marcia Reich, an astronomer, expresses her great shock by simply stating, "I am beyond cloud 9." Marcia Reich has been the research director for one of the telescope's main mechanisms, known as the NIRCam. Her partner, George Reich, has been the chief US scientist for another analytical device known as the MIRI. Marcia's group looks at the relatively short wavelengths that the telescope can interpret, while George's group looks at the longest wavelengths. Marcia Reich got to see the first pictures a few days before their release because she was asked to give a concise overview to help interpret them. The first one, called a deep field picture, is a patch of sky that from Earth is approximately the same as what would become occluded by grains of sand or a micrometeoroid held out at an equal distance. The Hubble Space Telescope discovered thousands of further galaxies than predicted after focusing on a similar region of sky for 2 weeks. The resulting photo, which took less than a single day to create, contains far more information and galaxies. We kept getting these galaxies that we weren't even searching for in the surroundings, no matter where we meant to point JWST, including during implementing images that would last a few tens of seconds, Reich said. Reich also confirmed that the team began to use identical galaxies as photobombers. She was taken aback by how gorgeously these images were, even though she knew mathematically that the diffraction was confined to a micron and that the length and width at half highest were whatever she knew they'd have beautiful images. I wasn't expecting many to appear so incredibly beautiful. If you start as a ground-based astrophysicist, this isn't the amount of information you're familiar with seeing, according to Reich. After her big mystery wore off, she focused her attention on the galaxies that showed up the reddest, indicating that their light had been traveling the lengthiest, perhaps well over 13 billion years. They reveal things about how the first galaxies developed and what components they contained. So now that we've got the picture, we'll begin the process of quantifying how luminous each spot is with each filter of measuring so that we can get an instant estimate of how far away the galaxy is. This resulted in a ranking of the most unique and fascinating galaxies, and what is fascinating varies depending on your personality and character to such information. If you are enthusiastic about the most distant galaxies, or those that display a black hole, another JWS instrument in IR spec can provide relevant information that opens up new lines of inquiry. Are there heavy elements in that galaxy, or is it so young that those heavy elements haven't formed? In September, a 10 times longer occurrence of a wide field indicated in a renowned Hubble picture will be taken, bringing reports of even earlier and thus flickering light. This light will be arriving from even closer to the earliest moments of our universe when the first little aggregates of stars have come around each other, Marcia said. As one of the astronomers who displayed the photographs live on NASA Live feed put it, each of the photographs each contained its own Easter eggs. One dying star was emitting vibrations of energy that revealed a second star near the area that the dying star was orbiting, and little rays of dying starlight were attempting to escape from the dust clouds in the same way that light from the sun would perhaps pierce through the clouds. Water vapor can be seen in the images of the exoplanet Wasp 96b. A dark billow in the cloud of dust and ionized gas presented a mystery in the image of the Carina Nebula, a birthplace of the stars. Reich believes that these images are the first step towards repaying the public for the $10 billion spent on the JWST for pragmatists. Okay, Webb can analyze exoplanets in painstaking depth. We can look for indications of global temperature transformation on an exoplanet and conduct research on that because we don't have any other illustrations in our planetary system where we can point a finger at the influence of carbon dioxide and other greenhouse gases, but Reich is extra convinced by many other types of gains. People require optimism and complexities, as well as the flavor of scientific breakthrough, she claims. For researchers, these pictures provide a perception of dimension in understanding our position within the universe. You may argue that who genuinely cares, but if we truly want to comprehend the universe, we must first comprehend how it functions. Some may find a number of specifics in these pictures to be less like Vermeer and more like Hieronymus Bosch, with pictures that are frighteningly alien or transcendent wherever you look closer in. Trying to take oneself seriously can be dizzying and perplexing until a new understanding of scale shifts that viewpoint. One might wonder why it has taken so much time to share Webb's first pictures. Since January the 24th, the spacecraft has been floating in space at the second Lagrange point, or L2, about 1 million miles from Earth. At 12, the gravitational pulls of the Sun and the Earth maintain Webb's movements around the Sun in consonance with the Earth's movement before it arrived. The telescope's components had to be meticulously unbound. The Sun component keeps the instruments cool so that they can precisely capture faint infrared light from the mirror's 18 gold-plated hexagonal pieces for the astronomers, engineers, and officials watching on Earth. It was a stressful time during the deployment. There were 344 single-point failures, which means that if any of the actions had failed, the telescope would have ended up as completely pointless space junk. In the period following the telescope's arrival at L2, the telescope's scientific instrument telescopes had to be turned on as well. In April, its technicians meticulously connected the 18 mirrors, the mid-infrared indicator, or MIRI, which demands the lowest temperature, was cooled to minus 447 Fahrenheit, allowing researchers to start a concluding round of testing. The science could begin after these and other steps were completed. Seeing these amazing pictures from NASA's Webb would have no doubt left you speechless, as it appears to have done to me also, and seeing this will push science to develop more exact calculations of distant galaxies. Given a half thought, second, it's completely insane that we now start noticing a radical turnaround from statistics to visual, particularly one with direct effect, and this is crucially significant. Even astronomers not affiliated with a specific discipline will require that form of bridge. Pictures, for example, have intellectual merit. The JWST Deep Field image may appear to be a galaxy of stars, but the key context is that we thought nothing existed there 30 years ago. The Hubble Space Telescope's director, therefore, used his time in 1995 to gaze at what was then registered as an empty spot in the sky. The image quality depicted thousands of galaxies of different ages, definitively challenging the notion of an indistinguishable universe. JWST has now acknowledged this and much more by looking even further.